Hi, I'm Ganesh, and in this video, we're going to build a .NET 10 CRUD API in 30 minutes using minimal API and Entity Framework core. So let's get started. First, we need to download and install Visual Studio 2026. So go to visualstudio.microsoft.com and click the Get Free Download button. Next, install Visual Studio by opening the downloaded file. And during installation, make sure that under Workloads, ASP.NET and Web Development is selected. And under Individual Components, scroll down a bit and make sure SQL Server Express 2025 Local DB is selected as well. Now let's start Visual Studio. Click Create a New Project. And in the search bar, type empty. Click the ASP.NET Core Empty template and click Next. Give the project a name, say Simple Book Catalog, specify a location, and click Next. Make sure .NET 10 is selected in the Framework dropdown. Leave the Configure for HTTPS checkbox checked. And finally, make sure use the .dev.localhost top-level domain in the application URL is selected as well. We will see what that is in just a bit. For now, click Create. The Program.cs class file contains the code that will execute when our application starts up. So it contains our application startup code. I talk more about this file in another video. The link to the video is in the description. At this point, all we have to know is that here we are registering a minimal API endpoint. So this means that when a GET request is sent to the root of the application, the block of code right here should be executed. Now, what is the URL of our application? If we expand the Properties folder in Solution Explorer and open the launchsettings.json file, under HTTPS profile, we have the application URL setting. This setting specifies the URLs at which our application will be hosted. Remember the option that we selected when we created the project? That option, which is new in ASP.NET Core 10.0, configures our project to use the .dev.localhost domain name suffix combined with our project name so that our application could be addressed at this URL. Let's close this file. Now, how do we test this endpoint? We can use an HTTP file. The HTTP file is used for creating and executing HTTP requests within our IDE. Right-click the project in Solution Explorer and select Add New Item. In the search bar, type HTTP, select this item, and click Add. To create a request for retrieving data from our server, we need to use the get verb. Say get followed by a space, and then we need to type in the URL. So if we go to the launchsettings.json file, we find our application URL. So let's copy it and paste it here. When we are using an HTTP file, we should simply use localhost. So let's remove this. Let's click Send Request. We got an error saying no connection could be made because we didn't start our application yet. So let's run our application and click Send Request. Since this request matches the endpoint that we registered using map-get, that endpoint got selected and executed. So we got a 200 OK status code indicating a successful GET request and the hello world text in our response body. Let's say we want to create another request. To separate multiple requests within the same .http file, we need to use a delimiter consisting of 3 hash symbols. This time, let's create a POST request. A GET request is for getting something from the server, while a POST request is used for sending data to the server. So let's say POST and copy this URL here. And let's specify a path to the resource, say /books. This endpoint does not exist yet. We'll be creating it in just a bit. Now, we need to send some data to the server. This data will typically be formatted in JSON, but you can also use XML. Let's use JSON for our demo. First, we need to set a header in the request called content type and specify the value application/JSON. Then we can pass in our data as JSON in the request body. So use a pair of curly braces and then pass in key value pairs. Say title and set it to ASP.NET Core in action, comma, price 37.00. If we run our application and click send request, we get a 404 status code because we don't yet have an endpoint that can handle that request. So let's create an endpoint that can handle a post request for the book's URL path. So open the Program.cs class file and let's define an endpoint. But before we do that, let's go to launchSettings.json file and set launch browser setting to false because we saw a web browser was automatically launched whenever we ran our application. Going back to the Program.cs file, to handle a post request, we need to use the mapPost method. So app.mapPost. Since the post request is being sent to the /books URL path, we provide the same. And then if our endpoint got selected, then we need to provide the block of code to execute. So use a lambda expression. For the expression body, let's use a statement lambda. So provide curly braces. Now in our endpoint, we need to retrieve the title and price data that is formatted as JSON in the request body. To do so, we can use parameter binding or model binding. Why do we need parameter binding or model binding? Let's imagine for a moment that the model binding infrastructure did not exist. Then, in order to get data from the request, we need to inject an HTTP request object and use the request object's read from JSON async method. Similarly, if you want to get data from query string parameter values, we need to say request.query and so on and so forth. And we have to convert the data that we got into our appropriate type as well. Imagine doing this for each and every handler, and it can become tedious and error prone. So instead, we can use a model class that is a data transfer object. So right click the project and select add new folder and name the folder models. Right click the models folder and select add class. Name the class book. Let's define a few properties. First, an ID property of type int, a title property of type string, and initialize it to string.empty, and finally, a price property of type decimal. Now all we have to do is to go to the Program.cs class file and define a parameter of type book for the lambda expression, and the book entity automatically gets its data from the JSON in the request body. Let's actually see that by returning book.title and book.price from our lambda expression. Let's run our app and send the post request. We got a 200 status code back with our title and price. Now, what if we send a request that contains invalid data? For example, a book's title is always required. So what happens when we pass in information without entering the book's title? We see the request was successful, but we got an empty string for the book's title. This is certainly not desirable. We want the request to fail with a 400 status code. We want to validate the data before accepting it in our handler. So we need to do model validation. If we were to do model validation manually, then we have to inspect the title property on our book instance and check if it is null or empty, in which case we return a 400 status code. With .NET 10, minimal APIs support model validation without having to validate our model manually or having to use external libraries like Fluent Validation. To enable validation, we need to register the validation services by calling builder.services.addValidation in our program file. Next, we need to apply data annotations or validation attributes on our model class properties to enforce validation rules. We can go to the book class and apply the required attribute on our title property to indicate that the title property must have a value. Let's bring in the system.componentModel.dataAnnotations namespace. So now validation will automatically occur on our book instance. Let's test it out. Run the app and go to the HTTP file and send a request without the title. We get a 400 bad request along with the model state error. So this is the desired behavior. Let's put the title back in. Now, once we have our model validated, we want to do something with that data. Maybe persist that data in a database. And since this tutorial is focused on building APIs, we're not going to follow any proper architecture. So we are going to use the book class as our domain model and our data model. We're going to use Entity Framework Core as our object relational mapper. In particular, we want the SQL Server implementation as we are going to use the SQL Server Express local DB database. And we will follow code first approach where we start from our book class, then create a context class, and then use migrations to create our database. Entity Framework Core is shipped as a set of NuGet packages. To install the NuGet package specifically for our database provider, which is SQL Server, let's go to Tools, NuGet Package Manager, and Package Manager console. And here, let's type in install-package Microsoft.entityframeworkcore.SQL Server and hit enter. Having done that, let's create our dbContext derived class. Right-click the project and select Add New Folder. Name the folder Data. Inside the folder, let's add a new class called Simple Book Catalog dbContext. This class has to inherit from dbContext, which is part of Entity Framework Core. Now we need to expose our book entity class as a public dbSetOfBook property. So let's do that. So this books property will be mapped to a books table in the database that we will create later. The properties of the book class will automatically become the columns in the books table. The ID column will automatically be the primary key, and it will be an identity column as well. The title column will have a default data type of nvarchar of max. Now these are the default conventions at work here. We can override these conventions using configuration. Configuration can be done either using data annotations or Fluent API, or we can use a combination of both. For example, we can use the max length attribute on our title property if we want to restrict the number of characters allowed on our title column. Or if we want to use the Fluent API, we need to override the onModelCreating method in our context class and specify our configuration. So modelBuilder.entity of book .property b goes to b.title .is required. So we are saying the title property needs to have a value, and then .has max length 200. So we are restricting the number of characters on our title column. In a similar way, we can set the precision and scale for our price property like so. Now we need to tell the context class about the database provider and connection string. This can be supplied at runtime. We can inject a dbContext options of simple book catalog dbContext into the constructor and pass the options to the base class constructor. Then we need to register the dbContext service in the ASP.NET Core's built-in dependency injection container. So go to Program.cs and say builder.services.addDbContext of simple book catalog dbContext, and then to the method we need to pass in a lambda expression. So say options goes to specify a code block. This block of code will execute when our context class is instantiated. So we can tell the context class exactly what database provider to use and what connection string to use. So say options.use SQL server. Here we can hardcode the connection string, but instead, let's say we store the connection string in some configuration file like the app settings file. So we can pull in the setting from configuration like so. Builder.configuration.getConnectionString and pass in the name of the connection string. This connection string does not exist yet, so let's create it now. Expand appsettings.json and double-click the appsettings.development.json file. The settings in this file will be used when our environment is set to development. After the logging configuration, use a comma and specify a connection strings section, and within that section provide a key value pair where the key is default connection, which is the name of the connection string, and set the value to server equals localDB // MSSQL localDB semicolon database equals simple book catalog semicolon integrated security equals true. Having done this, we are all set to create a migration. So go to Tools, NuGet Package Manager and Package Manager console. Before creating a migration, we need to install a set of tools. Let's install the NuGet package for the same. Install-package Microsoft.entityframework-core.tools. Now we can add a migration. Say add-migration and give a name for the migration like initial. This operation creates a source code file in the migrations folder, and it contains instructions on how to update our database schema to match the current state of our model. Next, we can use the update database command that will go ahead and create a database for us. So go to View, SQL Server Object Explorer, expand SQL Server, localDB, databases, and then you'll find here the database got created, simple book catalog. Expand that, then tables, and you'll find the books table. And further, the columns in the table are according to the configuration that we applied via the Fluent API. If we right-click the books table and select View Data, we see the table is empty. Let's go back to the Program.cs class file and right-click the tab and select Close Other Tabs. Just a quick recap. First, we sent a post request with the required data being sent as JSON in the request body, and then we accepted that data in our endpoint handler. So model binding and model validation was automatically done. Now we need to persist the model data to our database, and we created the database just now. Now we need to take the data in the model and save it. So we can use an instance of the context class for that. So the context object is used for querying and saving data. So if we want to perform creating, reading, updating and deleting operations, or simply called CRUD operations, we use the context object. So let's pass a simple book catalog DB context as a parameter. An instance of this class will automatically be injected by the DI container because we registered the required services. Then we can use the context object and access the books DB set and call the add method, passing in the book model. This line tells the context object to start tracking the book entity and sets the state of the entity to added. So the entity is new and does not yet exist in the database. The add method itself does not execute an insert command on the database. To do that, we need to call save changes or save changes async. If we are saving the data asynchronously, we need to use the await operator, and notice the async modifier is automatically added, and then call the context object's save changes async method. On a successful post request, we have to return a 201 created status code, which informs the client that the action was successful and a new resource was created on the server. To do that, we can remove this code and say results.created And we need to pass in a URL. This URL should point to the newly created resource, and it will be set as a location header in the response. And within double quotes, /books/ let's use string interpolation, specify $, within curly braces, pass in the ID of the book. We don't have an endpoint at this URL yet, but we'll create it in just a bit. And as a second argument, let's pass in the book instance. So this will be sent in the response body. Now open the HTTP file and run the app. Let's send the post request. And we see we got a 201 created status code in the response with the book information in the response body. And if we go to the headers tab, we see the location header being set to /books/1. So 1 is the ID of the newly created resource. Now let's construct a request to get a book by its ID. Copy the same URL as a post request and add /1, where 1 is the ID of the book that we want to get. Click send request. We get a 404 not found. So let's now create an endpoint to handle that request. So open the Program.cs class file and call app.mapGet. And as a first argument, pass /books/ within curly braces ID. The ID is kept in curly braces because it's what is known as a route parameter. So when a GET request is made to /books/1, the ID route parameter will capture its value. So ID will have the value 1. And as a second argument, we can pass in an async lambda expression because we know we will be using the await operator inside the expression. Since we want to retrieve the value of our route parameter, and we know that it will be an integer, provide an integer parameter called ID, and we want to use the context object. So let's inject simple book catalog DB context instance. Then we can say return await context.books.findAsync, pass in the ID. So this line of code retrieves a book entity by its primary key value, and we can check if it returns a non-nullable book instance, in which case we return results.ok passing in the book. So this indicates a successful GET request with a 200 status code along with the book information in the response body. If the returned book instance is null, we say results.notfound. So this returns a 404 status code. Let's run the app. Go to the HTTP file. First, let's send a GET request for a book that does not exist. We get a 404 not found status code. Now let's send a GET request for a book with ID 1 that does exist. As expected, we got a 200 OK status code with the book information in the response body. By the way, in our post request and our GET request, the address is the same. So we can define a variable at the top and set it to the address and use a variable in our requests. To create a variable, we need to use the symbol, say @address equals, and provide the address. And then to reference the variable in each of our requests, we use double curly braces like so. If we send this request, for instance, we get our hello world response. And let's reference the variable in our other requests as well. And once again, we can see our GET request is working as expected. Now let's construct a GET request to retrieve all books. So say GET, and the URL is the same as a post request. So within double curly braces, specify address and /books. And if we send the request, we get a different status code, 405 method not allowed. This is because we only have a single endpoint at that URL, and that endpoint can handle only post requests. So we don't have an endpoint at that URL that can handle GET requests. Open the program class, call the mapGet method, and pass in the URL path /books. And as a second argument, specify an async lambda expression, and inject the simple book catalog DB context instance. Now all we need to do inside this block is to return the list of books asynchronously. So say return await context dot books dot toList async. Let's run our app and send the request to get all books. Here we see a successful GET request with a 200 status code, but we have only a single book in the database. So let's create and send a POST request for another book, and once again send a GET request for all books. We see both the books in the response body. Now let's create a request to update an existing book. To do that, we need to use the put verb. So say put address /books/2, meaning we want to update the details of the book whose ID is 2. And we need to send the updated data in the request body. So specify content type application/JSON and provide the updated data in the request body. If we send the request, we get a 405 method not allowed because we don't have an endpoint for that URL that can handle a put request. Let's create that now. So go to program file and say app.map put and pass in the URL path /books/ within curly braces ID. Then pass in an async lambda expression. Here we need the ID of the book to update, the updated book information itself, and the simple book catalog DB context instance. Now we can do a bulk SQL update directly in the database without loading entities into memory first, like so. And then we can check if the number of rows that got affected was 0. In that case, the update operation was not successful. So we return a 404 not found by saying results.notfound. Otherwise, for a successful put operation, we need to return 204 no content. So say results.nocontent. Now we can run the application and send a put request for a book that does not exist. We get a 404 not found as expected, and then send the put request for the book with ID 2. We get a 204 no content in the response. So the book got updated. We can check this by sending a GET request for all books, and we see the second book has a new price. Finally, let's construct a delete request. For this, we need to use the delete verb. So say delete address /books/2, meaning in this particular request, we want to delete the book whose ID is 2. And once again, let's send the request. The request fails, and let's go ahead and create our endpoint. So go to the program file and say app.map delete, pass in /books/ID, and then pass in an async lambda expression. We need the ID of the book to delete and the simple book catalog DB context instance. First, we can get the book by its primary key and check if it returns a non-nullable instance, in which case we can say context.books.remove and passing in the book instance. This marks the book entity for deletion from the database, and the actual deletion occurs when we call await context.savechanges async, like so. Next, we can return a 204 no content response by saying results.nocontent. Otherwise, we can return a 404 not found response. So let's run our application and go to our HTTP file And let's try sending a delete request for a book that does not exist. We get a 404 not found error as expected. Now send a delete request for the book with ID 2, which does exist. We get a 204 no content status code. We can check if the book got deleted by sending a get request for all books. And we see the book with ID 2 is not there in the response. If you are interested in learning how to perform CRUD operations in Blazor using Entity Framework Core, check out the video on the screen right now.